Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 10 video on the chapter of exponents of real numbers, where I will discuss how do we compare exponents, how do we compare numbers, how do we compare exponential numbers like a to the power m, b to the power n, c to the power p, where all a, b, c, m and p are natural numbers. There are various form of comparison of exponents and radicals, which I will cover in the subsequent videos. In this part 10 video, I will discuss how to compare integers, natural numbers of the form a to the power m in the exponential form. So this video is part of the playlist CBSE Maths for class 9, following the textbook of author R.D. Sharma. If you like this video, if you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then subscribe to my channel, and in that case do not forget to press the bell icon so that you will be notified by my future videos. So let's start this video where I will discuss how to compare exponents of the form a to the power m, b to the power n, c to the power p, where all the a, b, c, m and p are natural numbers. Okay, so so the task is to compare numbers like the numbers in the exponential form, like a to the power m, where a and m are both natural numbers, and b to the power n and c to the power p. So here a, b, c, m and p are all natural numbers. Now before discussing how do we compare these kind of exponential numbers, it is essential to understand two important results. The first result is that if it is true that a to the power m is greater than b to the power m, where m, as you can see, the powers are same on both the sides, that is m, then this will imply that a is greater than b. And this implication also, if a is greater than b, then it will imply a to the power m is greater than b to the power m. So this is a double implication. X implies y means if x is true, then y will be true. And if we have y implies x, that is if y is true, then x is also true, then these two are combined. These two can be combined in a single implication, that is by saying x double implication y, that is if x is y, if x is true, y is true, and if y is true, then x is true. So if we have a to the power m is greater than b to the power m, then it will imply a is greater than b. Or if we know a is greater than b, then obviously a to the power m, then if we raise a and b to the same power of natural numbers, let's say m, so a to the power m will be greater than b to the power m. Similarly, it will be the same for less than operator. If a to the power m is less than b to the power m, this will imply a is less than b, and vice versa. That is, if a is less than b, then we will also have a to the power m less than b to the power m. But please remember that all these a, b, c, m, n, p are all natural numbers. Now in the first result, you can see that we were having same powers. In the result 2, the bases are same, but the powers are different. So if we have a to the power m greater than a to the power n, then this will imply that the power m will be greater than n, and vice versa. That is, if m is greater than n, then we will have a to the power m greater than a to the power n. Similarly, for the less than operator, if we have a to the power m less than a to the power n, this will imply m is less than n, and vice versa. Let's see. Let's try to understand this with some very basic examples. Now, in these examples, in the box, I will try to fill up with the less than or greater than operator. So I have to. So basically, we are trying to compare the two numbers on either side of the box. So 2 to the power 5 and 2 to the power 3, which is more. So obviously we can see the base are same 2. So and 2 to the power 5, the power is 5. 5 is greater than 3. So obviously 2 to the power 5 will be greater than 2 to the power 3. Similarly, let's say we have 16 to the power 3. We have to we have to find whether 16 to the power 3 is more or 16 to the power 4. Obviously 16 to the power 3 will be less than 16 to the power 4, as the base are same but the power 3 is less than the power 4. The number 3, the base are different but the powers are same. The powers are same, the base are different, so we will compare based on the base. 3 is greater than 2, so obviously 3 square will be greater than 2 square. Example number 4, we have 9 to the power 2x. We have to compare 9 to the power 2x and 9 to the power x, where it is given that x is a natural number. Now if x is a natural number, then obviously 2x is greater than 2x. If x is the natural number, then obviously we will have 2x greater than x. So then 9 to the power 2x will obviously be greater than 9 to the power x. Now example 5, x to the, we have to compare x to the power 4 and root over x raised to the power 4. We see the powers are same 4, so we have to compare the base. Now it is given that x is a perfect square. X is a perfect square. So if x is a perfect square, obviously it is not necessary for x to be a perfect square. X is always greater than root over x. So obviously this will be x to the power 4 will be greater than root over x whole raised to the power 4. The last example, we have to compare x plus 1 raised to the power n and x to the power n, where x is the natural number. X and n both are natural numbers. Now if x is the natural number, obviously x plus 1 is the next natural number, that is the successor of x. Then obviously we know for natural numbers a successor is always greater than its predecessor. So x plus 1 will obviously be greater than x. Since the powers are same, n, this x plus 1 to the power n will be greater than x to the power n. So I hope these two results are very, very fundamental. I don't think it will be difficult to understand these two results. So these two results will be used to compare numbers of the form a to the power m, b to the power n and c to the power p. Now the method or the strategy will depend on two cases. If the given numbers, that is a to the power n, b to the power n and c to the power m, falls under any of the two cases, case 1 and case 2, then only we will be able to compare them. Okay, so what is case 1? In the case 1, if the bases, so we have to compare a to the power m, the given numbers are a to the power m, b to the power n and c to the power p. So we can see in the given numbers the bases are a, b and c. If these bases a, b and c can be expressed as an exponent of a common base of x, let's say a, b, c, all these numbers can be expressed as an exponent with a common base x. So let's say a to the power a can be expressed as x to the power u, where u is some natural number, and b is x to the power v, and c is x to the power s. Then how do we compare the given numbers? So now what will a to the power m become? A to the power m now becomes, since we have expressed a in the form x to the power u, so this is x to the power u to the power m. This is x to the power m u. Similarly, b to the power n will be x to the power v whole raised to the power n. This is x to the power vn. And finally, c to the power p will be equal to x to the power s whole raised to the power p, which is x to the power sp. So essentially we have converted all the given numbers, that is a to the power m and b to the power n and c to the power m, c to the power p, to exponential form where the bases are same. The bases are same. Bases are all x. Now we just need to compare the powers, that is mu, vn and sp. So now we can say that mu, if we have mu is less than Vn is less than Sp, this will imply that obviously x to the power mu will be less than x to the power Vn will be less than x to the power Sp. So this implies x to the power mu was a to the power m. So a to the power m will be less than a to the power n will be less than a to the power m will be less than b to the power n will be less than c to the power p. Now for if mu is less than Vn less than Sp, then we will have this. So quite obviously, if we have mu greater than Vn greater than Sp, then this will imply obviously that x to the power mu will be greater than x to the power Vn will be greater than x to the power Sp, and this implies a to the power m will be greater than b to the power n will be greater than c to the power p. Now in this less than and greater than operator, if it is less than equal to, then if it is instead of less than operator is instead of less than, if we have less than equal to, then it will also reflect here. I mean, if it is that if we find that mu is less than Vn is less than mu is less than equal to Vn is less than equal to Sp, then this will imply a to the power m will be less than equal to b to the power n will be less than equal to c to the power p. Similarly, if we have mu greater than equal to Vn greater than equal to Sp, then this will imply a to the power m will be greater than equal to b to the power n will be greater than equal to c to the power p. So this way we can compare the given numbers if the bases of all the given numbers can be expressed as an exponent of a common base. Let's see some examples. So we have to compare 2 to the power 8, 4 to the power 3 and 16 square. Clearly we can see the bases 2, 4, 6 can be 2 is already 2 cannot, so 2 is 2, the 4 base can be expressed as, so 2 can be expressed as 2 to the power 1, 4 can be expressed as 2 square, and 16 can be expressed as 2 to the power 4. So the number becomes 2 to the power 8 is equal to 2 to the power 1 whole raised to the power 8, which is 2 to the power 8. 4 to the power 3 is equal to 2 square whole raised to the power 3, which is equal to 2 to the power 6, and 16 square is equal to 16, the base when expressed as a power of 2 to the power 4, this square, and this is equal to 2 to the power 8. So the numbers are 2 to the power 8, 2 to the power 6 and 2 to the power 8, where we are having the same base of 2. Since we know that 6 is less than 8, 6 is less than 8, this will imply that 2 to the power 6 will be less than 2 to the power 8, 2 to the power 8, and also we are having 2 to the power 8 is equal to okay. So since 6 is less than 8, obviously we will have 2 to the power 6 is less than 2 to the power 8. So now, what was 2 to the power 6? 2 to the power 6 was 4 cube. So 4 cube is definitely less than 2 to the power 8, and 4 cube is also less than 16 square, because 16 square is also equal to 2 to the power 8. So if we arrange the given numbers in the ascending order, it will be 4 to the power 3, comma 2 to the power 8, comma 16 square. So the given numbers in the ascending order will be 4 to the 4 cube, 2 to the power 8 and 16 square. Let's see another example. So we can see the numbers are 81 raised to the power 18, 243 raised to the power 15, 27 raised to the power 21 and 9 raised to the power 38. If you see the bases, the bases can be clearly expressed as a power of 3. So 81, so the numbers are 81 when expressed as a power of 3 will be 3 to the power 4. So first number is 3 to the power 4 whole raised to the power 18. The second number is 243. If expressed as a power of 3, it will be 81. Okay, so it will be 3 to the power 5. 243 is equal to 3 to the power 5, 15, and 27 is 3 to the power 3, and 9 is 3 square. So we have expressed all the bases of the given numbers as a power of 3. Now if I further simplify the given numbers, it becomes 3 to the power 72, because applying the laws of exponents, the power will become 18 multiplied by 4, and we have 3 to the power 15 multiplied by 5, which is 75, and 3 raised to the power 21 multiplied by 3, that is 63, and 3 to the power 32 multiplied by 38 multiplied by 2, which is 76. So now we have to compare these numbers, where these exponential numbers where the bases are same 3. So we will compare them based on the powers. Clearly, since we know 63 is less than 72 is less than 75 is less than 76, so this will imply 3 raised to the power 63 will be less than 3 raised to the power 72 will be less than 3 raised to the power 75 will be less than 3 raised to the power 76. So this implies that 3 raised to the power 63 was 27 raised to the power 21. So this will be less than 3 raised to the power 72 was 243 raised to the power 15. 3 raised to the power 75 was 27. No, sorry, I think I am doing some mistake. 3 raised to the power 63 was 27 to the power 21. Okay. 3 raised to the power 72. 3 raised to the power 72 was 81. Sorry. 3 raised to the power 72 was 81 raised to the power 18, and 3 raised to the power 75 was 3 raised to the power 75 was 243 raised to the power 15, and finally 3 raised to the power 76 was 9 raised to the power 38. So this is the ascending order of the given numbers. So this was case 1, where all the bases of the given exponential terms can be expressed as a power of the same base. Let's see case 2. Now in case 2, definitely, obviously in case 2, the bases ABC will not be able to we cannot express the bases ABC as a power of some common base. So the strategy we will use is that if we see that if we find that the GCD, or the highest common factor of all the powers of the given exponential terms, is greater than 1, then we will find the HCF, highest common factor, or the greatest common divisor of all the powers of the given numbers. So as we know that the numbers are the numbers that we need to compare are a to the power m, b to the power n, and c to the power p. So let's say the HCF of the powers, that is mn and p, is equal to L, and L is greater than 1. Now let U be equal to m by L and V be equal to n by L. That is, we divide all the powers by their HCF, by their highest common factor, HCF or GCD. So let U be equal to m by L, V is equal to n by L, and S is equal to p by L. Now this implies that okay, what next? Well, okay, so now we see that m is equal to UL, n is equal to VL, and p is equal to SL. So the the given numbers becomes a to the power m becomes a to the power UL, which is equal to a to the power u whole raised to the power L. The number b to the power n becomes b to the power VL, which is equal to, I can express this as b to the power V whole raised to the power L, and the number c to the power p is equal to c to the power SL, which can be written as c to the power s whole raised to the power L. Okay. Now let's say let a to the power u, okay, not required. So now we have to compare these three numbers, and we can see that all these three numbers are having the same power, L. So obviously we will compare by the base. So if we have a to the power u is greater than b to the power v is greater than c to the power s, this will imply that a to the power u, we can raise all of them to a common power, which is a natural number. We will have b to the power v raised to the power L greater than c to the power s raised to the power L. So this implies a to the power u whole raised to the power L was a to the power m, b to the power n, and c to the power p. Similarly, if the inequality relation between a to the power u, b to the power v, and c to the power s is the other way around, that is, if it is a to the power u is less than b to the power v is less than c to the power s, this will imply that a to the power m will be less than b to the power n will be less than c to the power p. Okay, let's see how we apply this concept in an example. So we have to compare. As you can see, there are three exponential terms. All the bases are different. We cannot, the bases are 2, 3 and 5. We cannot express them in the exponential term with a common base. So now we will see whether the HCF of all the powers is greater than 1 or not. If it is greater than 1, then hopefully we will be able to compare them. So now we have to find the HCF of 1465, 1172 and 879. We have to find L, that is the HCF of all the powers. So 1465, 1172 and 879. 11, 3. Will you divide by 3? 4. No. Will you divide by 7? No. What will be the HCF? Okay, let's see. I will. So this is where I am very slow. I'm really sorry for this. I will prime factorize. I will have to prime factorize all the numbers. So 2, 9 and 3. 10, 14. And then 293. 293, 12, 11, 14, 7, 38, no, 9, 27, 23. Let's see, 1172, 1172, 4, 4 to the 8, 9, 3. Okay, I see. So I think 293 should be the HCF. Let's see, 879. If I divide by 293, it should be 3. Okay. So clearly we can see that the HCF of all the powers is 293. Now, so so basically we will factorize the powers. So 1465 is 293 multiplied by 5. 3 to the power 1172 is 293 multiplied by 4, and 879 is 293 multiplied by 3. So now we will re-express these numbers as 2 to the power 5 whole raised to the power 293. Remember that we will express all the given numbers in exponential form, where the power will be the HCF of the powers of the given numbers. So this becomes 3 to the power 4 whole raised to the power 293, and we have 5 raised to the power 3, this whole raised to the power 293. If we simplify the bases, we have 2 to the power 5 is 32. So 32 to the power 293, 3 to the power 4 is 81. 81 to the power 293, and 5 cube is 125. 125 to the power 293. So clearly we see, now we have to compare these three exponential terms. Clearly we see all the powers are same, that is 293. So we have to compare based on the bases. Clearly we can see that 32 is less than 81 is less than 125. So this will imply that 32 raised to the power 293 will be less than 81 raised to the power 293 will be less than 125 raised to the power 293. And 32 raised to the power 293 was 2 to the power 1465. This will be less than 81 raised to the power 293 was 3 to the power 1172, and we have lastly we have 5 to the power 879. So this will be the given numbers in ascending order. So this was all. I hope I was able to explain the case 1 and case 2 using which we can compare exponential terms like a to the power m, b to the power n, and c to the power p, where all abc and mn and p are all natural numbers. If you are given some exponential terms where abc and mn and p are all natural numbers, and it does not fall on in either of the cases, case 1 and 2, then obviously you won't be then obviously you have to use some other method for comparing them. Case 1, you can use the case 1 method only when the basis of the given exponential terms can be expressed as a power of some common base, and you can use the case 2 when all the bases are different, that is, all the bases you cannot express as in the exponential form with the common base, but the powers of the given numbers will have HCF greater than 1. Now, based on these concepts, I will try to solve more problems in the next video. So please stay tuned. If this video was beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I am ending the video here. Thanks for watching, and until the next video, take care and bye.